to my channel. I am Hajra Mughal, your physics mentor, and I'm thrilled to see you again. Today we are diving back into our Mdcat and Ecat prep series, and I'm excited to share more insights and strategies to help you master physics and achieve your academic goals. So let's get started and make today count. Today we will be exploring the topic of thermodynamics through multiple choice questions. This will help you assess your understanding, reinforce your key concepts, and feel more confident as you prepare for your exams. So let's get started. To excel in multiple choice questions on this topic thermodynamics, it is essential to review the following key concepts: laws of thermodynamics, zeroth, first and second law, work done on gases, applications of first law of thermodynamics like isobaric, isochoric, isothermal and adiabatic process, molar specific heat at constant volume and at constant pressure, and the relationship between Cp and Cv. So students, first MCQ is first law of thermodynamics deals with quality of energy, quantity of energy, both quality and quantity of energy, and none of these. So students, remember that the first law of thermodynamics deals with the quantity of energy, not the quality of energy. So first I will mark the correct answer, okay? How? The first law, students, also known as the law of conservation of energy, and it states that energy cannot be created or destroyed, only converted from one form to another. Or in other words, you can also see that the total energy of an isolated system remains constant, and it is the mathematical formula that del E is equals to Q minus W. The net change in total energy is equivalent to heat added minus work done. This expression will give you the quantity of energy. So this law focuses on the quantitative aspect of energy, meaning it deals with the amount of energy, not its quality or form. So students, next MCQ is which of the following has single, or you can say one value of a specific heat capacity, and these are the options. So students, solid and liquids typically have a single specific heat capacity value, which is usually measured at constant volume, and gases have two specific heat capacity because their thermal properties depend on whether the volume or pressure held at constant during heating or cooling. In contrast, solid and liquids are generally incompressible, so their specific heat capacity is typically measured at constant pressure. So the correct option is both B and C. So next MCQ is the heat supplied to a gas at constant volume. So the heat supplied to a gas at constant volume can be written as the heat supplied to the mass m of a gas to increase its temperature del T is given as m Cv del T. M is the mass, Cv is the specific heat capacity at constant volume, and del T is the increase in the temperature. So the correct option is A. So next MCQ is conversion of heat energy into work violates which law? Zeroth, first, second, both B and C. So according to second law of thermodynamics, it's impossible for an engine to extract heat from hot reservoir and convert it completely into useful work. So there must be some any sort of you can say the loss of heat or loss of energy. So this is the second law of thermodynamics which is violating over here. When gas is heated at constant pressure, the heat supplied is utilized in, and the options are these. So students, when a gas is heated at constant pressure, the heat supplied is utilized in two ways. First is internal energy and the work done, and mathematically it can be written as del Q equals to del U plus del W, where del Q is the heat supplied and del U is the change in internal energy and del W is the work done. So at constant pressure, the work done is equivalent to the pressure times the change in the volume. So heat supplied is utilized in increasing the internal energy of the gas and doing work against the external pressure. So correct option is C. So next MCQ is the sum of internal energy and the product of pressure and volume is known as, so students, it's known as enthalpy, and mathematically it can be represented as H equals to U plus PV, and U is internal energy, P is pressure, V is volume, and H is the symbol of enthalpy. Students, enthalpy is a thermodynamic property that represents the total energy of the system, total energy of the system, okay, including both internal energy and the energy associated with the pressure and volume of a gas or fluid. It's a useful concept in thermodynamics, especially when dealing with the process at constant pressure. So the correct option is C over here. According to first law of thermodynamics, which statement is correct? The total internal energy of a system during process remains constant. Total energy of the system remains constant. Work done by a system equals to heat transferred by a system. Internal energy and entropy during a process remains constant. So students, first law of thermodynamics is all about energy conservation, okay, and it states that total energy of the system remains constant. So correct option is B. Absolute zero is equivalent to 0 Kelvin minus 273 degrees Celsius minus 459 degree Fahrenheit and all of the above. So students, you can see from this diagram the absolute zero is equivalent to 0 Kelvin minus 273 and minus 459 degree F. So the correct option is all of the above. Students, remember one thing, the absolute zero is basically a theoretical temperature. It's a theoretical, 1 minute, theoretical temperature, okay, at which all matter would have zero entropy, meaning that all molecular motion would cease. It's the lowest possible temperature and serve as the foundation of this Kelvin scale. If CV is molar specific heat and del T is temperature, then CV and del T, the product of CV and del T gives, so students, the formula is del Q equals to NCV del T. If I take this N on other side, so CV del T, the product of CV and del T is equivalent to del Q over N. So it is known as heat energy. So the correct option is energy. A system undergoes an isothermal contraction such that the pressure increases from 100 kilopascal to 400 and the volume of the system decreases from 4 centimeter cube to 1 centimeter cube. Then the change in the internal energy. So students, if the process is isothermal process, then the change in the internal energy is zero, since the temperature remains constant, because iso means same and thermal means temperature. If the temperature is constant, then the internal energy will be zero. So the answer will be zero here. Okay, so next MCQ is the equation for isochoric process. So in isochoric process, the work done is 0. Why work done is 0? Isochoric means constant volume. So the formula of work done is the product of P and del V. So if the volume is constant, means the volume is not changing, so del V will be 0, so work done will be 0. And according to first law of thermodynamics, del Q equals to del U plus del W. So if it is 0, then del Q will be equivalent to del U, so C is correct option. The necessary condition for the Boyle's law to hold is that the process must be. So students, the Boyle's law gives the relationship between the pressure and the volume, but the temperature must be constant. So isothermal, iso means same, thermal is the temperature. So isothermal is the condition that must be hold for this law. So students, next MCQ is the sum of all form of molecular energy is in a thermodynamic system is known as. So students, the sum of all forms of molecular energy in a thermodynamic system is known as internal energy of the system. That includes kinetic energy of molecules, translational, rotational, vibrational or potential energy of molecules, and electronic energy and the nuclear energy. Students, internal energy is a fundamental concept in thermodynamics and is a measure of total energy of a system due to motion and configuration of its molecules. The efficiency of Carnot engine working between 177 degrees Celsius to 77 degrees Celsius. So student, first of all, we will make a data. The temperature of a hot reservoir is given as 177 degrees Celsius, and when you convert it into Kelvin, so it will be 450 Kelvin. And the temperature of the cold reservoir is 77 degrees Celsius, and after conversion it will be 350 Kelvin. Now the formula to calculate efficiency is 1 minus the temperature of the cold body and the temperature of the hot body divided by and multiply by 100. When you substitute the value 1 minus 350 over 450, then multiply by 100. So 1 minus 350 over 450 is 0.777, and when you subtract it, so answer will be 0.222, and when you multiply it by 100, so answer will be 22.22%. So correct answer is option A. Thanks for joining me today, students. We have covered some great multiple choice questions on thermodynamics, and I hope you found it helpful. Don't forget to subscribe to my YouTube channel and click the notification bell to stay updated on our latest content. In our next video, we will be tackling multiple choice questions on electrostatics, so be sure to tune in for that. See you in the next video.